Good morning. The topic I'm going to take is about Introduction to Refrigeration, and the topic is refrigerants, its classification and thermodynamic properties. Any substance that absorbs heat through evaporation is known as refrigerant. It is a medium of heat transfer which absorbs heat by evaporation at low temperature and gives up heat by condensing at high temperature and pressure. Broader definition includes secondary cooling mediums like cold water and brine solutions. Wildest applications at present are ammonia or halocarbons. Refrigerant. What is refrigerant? It is divided into two types. It is primary and secondary refrigerant. Refrigerant is the fluid which is used for heat transfer in a refrigerating system that absorbs heat during evaporation from a region of low temperature and pressure and releases heat during condensation at a region of higher temperature and pressure. Then we are going to discuss about the various desirable characteristics of refrigerants. First one, it should be non-poisonous, it should be non-corrosive, it should be non-inflammable, that is, it should not be flammable, it should not have any leaks, and it should not be easily detectable. It should have a low boiling point, it should have a stable gas, it should have a suitable latent heat and a low specific volume. The minimum difference between evaporating and condensing pressure. One further classification of derivable properties. They can be categorized as thermodynamic, physical and chemical properties. Then we are going to discuss about some of the important refrigerants. First, it's about carbon dioxide. Carbon dioxide is widely used as refrigerant in mechanical systems, marine services, hospitals because of its excellent safety properties. It is a odorless, non-toxic, non-flammable, non-explosive and non-corrosive substance. Next, we are going to discuss about sulfur dioxide. Sulfur dioxide was widely used as refrigerant during the 20th century. However, right now it has been restricted because it has many disadvantages, such as it has highly toxic, non-flammable, non-explosive, non-corrosive and works at low pressures. Next, we are going to discuss about ammonia. Ammonia is one of the earliest types of refrigerants which is still widely used in many applications due to its inheritance in excellent thermal properties. It is toxic in nature, flammable, explosive under certain conditions, but it has low specific volume, high refrigerating heat, high refrigerating effect, low piston displacement in case of reciprocating compressors, which make it ideal refrigerant for cold storages, ice plants and packaging plants. Next, Freon 11, also called as trichlorofluoromethane. It is used under low operating pressures. It is non-toxic, non-corrosive and non-flammable. Due to its low operating pressure and high displacement, it is used in systems employing centrifugal compressors. It is also used for air conditioning applications. Next, about Freon 12. Freon 12, also known as dichlorodifluoromethane. It is non-flammable, non-toxic and non-explosive. It is highly chemically stable. If it is brought into contact with open flame or heater elements, it decomposes into highly toxic constituents. It has not only excellent safety properties but also condenses at moderate pressures under normal atmospheric conditions. Next, about cryogenic refrigerants. Cryogenic refrigerants are those which produce minus temperature ranges, that is below 0 degree, that is between the range of 157 degrees Celsius to minus 273 degrees Celsius, which is the lowest point at the refrigerated space. The cryogenic refrigerants have a shallow boiling point at atmospheric pressure. Some of the widely used cryogenic refrigerants are helium, nitrogen, oxygen and hydrogen. Then we are going to discuss about the properties of refrigerants. Some of the common properties some of the common properties of refrigerants we have discussed earlier, and in this we are going to see some common refrigerants like ammonia, carbon dioxide, methyl chloride and fluorocarbons. They are usually used in domestic and industrial applications. And in fluorocarbons we can see freon 11, 12, 13, 22, 113, 114, etc. Methyl chloride, it is used in domestic and industrial refrigerators. These chemicals damage the ozone layer and hence they are being replaced right now. There are two types of refrigerants. One is primary and second one it is secondary refrigerants. Primary refrigerants means the working mediums or heat it is carried which directly takes part in the refrigeration systems and cool the substance by absorption of latent heat are called primary refrigerants. For example, freon, ammonia, carbon dioxide, sulfur dioxide, etc. Secondary refrigerants. These are the circulating substances which are first cooled with the help of primary refrigerants and then employed for cooling purposes. For example, ice, solid carbon dioxide, chilled water, and brine solutions. Properties of refrigerants. They should have low freezing point, boiling point, evaporator and condensing pressure, and these are the thermodynamic properties like low freezing point, low boiling point, evaporator and condenser pressure, coefficient of performance and power requirements, latent heat of vaporization, specific heat for low for liquid, high for vapor, and specific volume which is low for vapor. First, then about chemical properties. It should be non-toxic, non-flammable, non-explosive, non-corrosive to metal, and should have high latent heat of vaporization. If we see physical properties, it should have low specific heat, a low specific volume of vapor, a low viscosity. Then the dielectric strength, it should have high for use in hermetic compression, and the thermal conductivity should be high. Now we are going to discuss about thermodynamic properties. For boiling point, the boiling point of the refrigerant at atmospheric pressure should be low. For example, in this refrigerant, R11 has 21.7, however in R12 it is minus 29, R21 is plus 9, R22 is minus 41, and so on. For freezing temperature, it should be well below the operating evaporator temperature. For example, in R12, the freezing temperature is minus 157.5. For R22, it is minus 160, or R113, it is minus 35. Evaporator and condensing pressure. For both the evaporator, low side, and condensing high pressure, it should be positive, and it should be as near as the atmospheric pressure as possible. For example, in R12, we see the evaporating pressure is 1.82, and for condensing pressure it is 7.45, and the compression ratio is 4.08. In R113, we see the evaporating pressure is 0.06 and condensing pressure is 0.54, and the compression ratio is 8.02. Now critical temperature and pressure. The critical temperature of a refrigerant, it is the highest temperature at which it can be condensed to a liquid regardless of high pressure. For example, an R21 has a critical temperature of 178.5 degrees Celsius and a critical pressure of 51.65 bar. R40 has a critical temperature of 143 degrees Celsius and a 66.83 bar pressure. R744 has a critical temperature of 31 degrees Celsius and 73.8 bar. Now, coefficient of performance and power requirements. For an ideal refrigerant, the operating pressure should be between minus 15 degrees Celsius evaporator temperature and 30 degrees Celsius condensing temperature. For example, if we see R22, the coefficient of performance is 4.66 and the power requirement for this is 0.753 kilowatt per ton. Now, latent heat of vaporization. A refrigerant, it should have a high latent heat of vaporization at the evaporating temperature. For example, R40 has a refrigerant effect of 350 and a latent heat of vaporization of 421 and mass refrigerant of 0.6 kg and a volume of 0.67 m3. Then about the assessments. For example, what is the desirable characteristics of refrigerant? It should be non-toxic, non-corrosive, all the above. Second one, disadvantage of ammonia is that it is highly toxic in nature. And these are the other two assessments. Thank you.